All right, limit of absolute values. This question here is giving us the limit as x approaches the number 2. Obviously, by looking at this, as x becomes 2, if this number is 2 and this number is 2, we're left with an indeterminate number because we have 0 divided by 0. I can't write that in that pen, I apologize. Okay, we'll have 0 divided by 0, so it's just indeterminate. Now, depending on which way we're approaching the number 2, whether we're coming at it from the left or coming at it from the right, in other words, if x is greater than 2 or if x is less than 2. Okay? So we're going to kind of split this into a piecewise function where we have f at x is equal to the absolute value of x minus 2 divided by x minus 2. And what we have here is we know for a fact when x is greater than 2, okay, we're going to be left with a value that's still going to be positive on top, so we can really just leave this as x minus 2, okay, because if our number is greater than 2, we still have a positive value in there, and we're still divided by x minus 2. Sorry, I should have made this a little larger. That's part of our function. So that's if x is greater than 2. And if x is less than the number 2, okay. Again, we have x minus 2 on top. The only difference is our value would technically be a negative number, okay. X minus 2. And what we mean by that is because we know if it's absolute value, it's still going to give the same positive result. But if we have a number less than 2, for instance, the number 1, closest whole number, we're going to end up with the number negative 1. Okay? But the absolute value would take away our negative, so we really wouldn't know where we are on the graph here. So when these are true, okay, what we're going to figure out here is we're going to go through this, and we're going to talk about numbers that are infinitely close to 0 as an x value. Okay? And what we would mean by that is x is greater than 2. What we can do to help solve these, if this number is infinitely close to 0, we're kind of being left with what would be a negative or a negative 2 here. Maybe this will be easier if we start up here. If we have a number that is infinitely close to 0 in this case, okay, what's going to end up happening is we're going to have negative 2 divided by negative 2, which is going to give us a value of 1. So what that says is, for our absolute value, if x is greater than 2, then our value when the number is greater than 2 is essentially number 1. Okay. And the same idea, if we have a number infinitely close to 0 or 0 itself, we're left with negative 2 divided by negative 2, which again gives us 1, but because we know it's a number less than 2, we're going to be left with our negative 1. So if x is less than 2, we're left with negative 1. Okay. Now, the reason we've gone about doing this, and the reason also doesn't even have to be 0. Think of this as if we're canceling these terms. Okay. Because we have x minus 1 and x minus 2 and x minus 2, we know if we divide the two of them, we're left with just the term 1. Okay. And again here, if we divide the two of these, we're left with the term 1, but because x is technically negative, we are left with a negative 1. Okay. So we have 1 and negative 1 as our terms. So if we were to draw a graph of something like that, knowing that 2 is our very important piece here, bring in our graph. Here we go. Okay. So what that means is when x is greater than the number 2, so at the value of 2, and we're going to put a dotted line across there for now. We'll get rid of it after. But when x is the number 2, this is our cutting point. Okay. Our y value, or f at x, is equal to the value of 1. So we'll do that in red when we're greater than 2. So we're at the value of 1. And when the number is less than the number 2, we're at a value of negative 1. Okay. So we have values like this one going through it. So what we can talk about now is, because we know we're actually not at the number 2 here, right? 2 is where we're cutting everything. But we can talk about approaching 2 from the left and the right. And the way they usually describe those limits is the limit of x as it approaches 2. And from the right means in a positive direction. So think of it as you're coming from positive infinity. And from this direction, if we're approaching the number 2, we'd say the limit of x as it approaches 2 from the left. Okay? And then negative just refers to the being left of the y-axis. Okay? So we're coming at it from negative infinity and we're coming at it from positive infinity. Well, what happens here is, because again, we're not actually using the number 2 when we find a limit. We're using a number that's infinitely close. We're coming along and our value just before we get to 2 is what on the y-axis? What's our value here? We're at negative what? 1. We're at negative 1. So when we write this limit, okay, after we've graphed it, think of it like this. The limit of x as it approaches 2 from the left, let it catch up, okay, as f approaches 2 from the left is our constant term, which is negative 1. So the limit of negative 1 as x approaches 2 from the left, well, because it's a constant term, we know it's just going to be negative 1. And the same idea happens for the limit of 1 as x approaches 2 from the right. Well, because it's a constant term again, we're just going to be left with the limit being the number 1, or the value of it being the number 1 here. So it didn't matter if we're approaching from the left or right. We did have these, but the limit at 2 does not exist. Okay? We can't find the limit of x as it approaches 2 as an absolute value. We can only find it as it approaches from the left and approaches from the right. It doesn't actually exist from on the number 2. Okay? So because we're able to define it from the left and the right, we have our negative 1 and our 1, but it does not exist when it's at 2.